Welcome to our Deep Learning series. Today, we're diving into the fundamentals of neural networks and deep learning. Join us for an enlightening journey into the world of artificial intelligence. What is a neural network? A neural network is a computational model inspired by the human brain. It's made up of layers of nodes, or neurons, that process data to make predictions. These neurons work together, learning patterns from data to improve predictions. When we talk about artificial neural networks, RNNs, we refer to these models specifically designed to handle various tasks like image recognition, language processing, and more. Components of an artificial neural network. Artificial neural networks consist of three main parts. The input layer receives data, hidden layers process this data through weights and biases, learning complex patterns. Finally, the output layer provides predictions or classifications based on what the network has learned. Deep neural network. When a neural network has more than one hidden layer, it's called a deep neural network, DNN. These networks can learn complex patterns from data due to their deep architecture. Training neural networks. Learning involves feeding the network large amounts of data and allowing it to adjust its weights based on the errors it makes, a process called training. Over time, the network becomes better at making predictions. Activation functions. An activation function in a neural network is a mathematical function that determines the output of a neuron. It takes the weighted sum of inputs and applies a nonlinear transformation, enabling the network to learn and model complex data patterns. Common activation functions include sigmoid, logistic, rectified linear unit, ReLU, and hyperbolic tangent, TAN. Each function has unique properties that make it useful in different scenarios. Introduction to deep learning. Deep learning is a subset of machine learning that uses deep neural networks with multiple layers to model complex data. It's particularly effective for tasks like image and speech recognition. Deep learning has a wide range of applications, including voice assistants, autonomous vehicles, and facial recognition. Key concepts in deep learning. Feedforward neural networks, FNNs, move data in one direction with a simple structure of input, hidden, and output layers. Each neuron in one layer is connected to every neuron in the next layer, making it fully connected. They are typically trained using backpropagation, adjusting weights based on the error rate, and are commonly used in image and speech recognition. Convolutional neural networks, CNNs, are excellent for processing images by learning spatial hierarchies. A convolutional layer acts like a filter, scanning an image to identify specific patterns like edges, shapes, or textures. As the network progresses through multiple convolutional layers, it learns increasingly complex features, building a hierarchical understanding of the image. CNNs automatically learn features from the data, making them powerful and adaptable to various image recognition tasks. Recurrent neural networks, RNNs, handle sequential data, making them suitable for language processing. They process information step by step, considering the current input and information retained from previous inputs. This internal memory allows RNNs to capture relationships and dependencies within sequential data. Deep learning frameworks, TensorFlow and PyTorch. Now that we've covered the basics of neural networks, it's time to explore the tools that make deep learning accessible. In this segment, we'll focus on two popular frameworks, TensorFlow and PyTorch. These frameworks are essential tools for anyone looking to dive into deep learning. First, let's talk about TensorFlow. Developed by Google, TensorFlow offers a comprehensive ecosystem for building and deploying machine learning models. It provides a range of tools and libraries that simplify the development process. TensorFlow's scalability makes it suitable for both beginners and advanced users. Next, we have PyTorch, developed by Facebook. PyTorch is known for its dynamic computation graph, which allows for more flexibility during development. This makes it particularly popular among researchers and developers who need to experiment and iterate quickly. Both frameworks have extensive documentation and strong community support, making it easier for beginners to get started. Whether you choose TensorFlow or PyTorch, you'll have a powerful toolset at your disposal to create deep learning models. Conclusion. That's all for today. In our next video, we'll get hands-on and implement a simple neural network. Don't forget to like, subscribe, and hit the bell icon for more updates.